Today we'll be talking about the circular disk method of finding the volume of the solid that is rotated about an axis. Suppose we had a rectangle having its base along the line L, and if this plane area is rotated about a line in its plane, the solid thus generated a solid of revolution. But in our example here, it generated a circular disk. So we'll be using the circular disk method of finding the volume of the solid. Now, and the line at which the area is rotated is called an axis of rotation. This line, this is what we call the axis of rotation. To further understand, we have here a graph that is bounded by x is equal to a and x is equal to b. And if the area under the curve is rotated about the x-axis, it then produces a solid that looks like a vase. Now, how can we determine the volume of the generated solid? From the definition of the definite integral, we can find the area under the curve by taking a small strip of rectangle having its width resting on the axis of rotation, which in the x-axis. So we denote this as dx. And the length touching the upper curve of the function, denote this as our y, or our length of the rectangle. This is also the same if we revolve the area about the x-axis, then it produces a rectangular element that will sweep out a cylindrical element or a circular disk. From the generated solid, we can find the volume using the formula V is equal to pi r squared h. Note that from our rectangular element here, the length y becomes the radius of the solid, so this will become our radius, so this is our y, and the width becomes our height. Then we can create a differential volume, that is dV is equal to pi, so our radius here will be our length of our rectangle element, so this will become pi y squared. Then our height of our circular disk is our dx, or our small change of x, so this will become dx. Now, from the fundamental theorem, we can get the sum of all solids by integrating our differential volume. So integrating this with our limits of integration that is bounded from a to b, so our differential volume will become V is equal to pi, since pi here is a constant, so integrating a constant is still a constant, so therefore this is a pi integral of y squared dx, and it is bounded from a to b. Note that you must express the y squared in terms with x. Suppose we have, if our graph here is equal to the function of x, so we must substitute the value of y as our x here. So we can rewrite our formula as v is equal to pi integral of f of x dx, and it's bounded from a to b. The same process if we rotate our area of under the curve along y-axis. So we must take a small strip of rectangle having its base resting along the y-axis. So this will be our dy, and the length of our rectangular element here is x. We can express a formula on finding the volume, that is, volume is equal to pi integral of x squared dy. It is bounded from c to d. So our x here is our radius of the solid, and dy here is the height of the solid. So we can find the volume of that is rotated about the y-axis. So in general, in order to familiarize the formula better, we can write the formula, that is v is equal to pi integrated from a to b and L squared dh. So you must remember the the rectangular strip that is our length and our height is dh. Okay, we have here an example. Find the volume of the solid generated by revolving about the x-axis. The area bounded by y is equal to square root of x, and it's bounded from x is equal to 4 and the x-axis. Now, feel free to pause this video and answer it on your own. So in order to solve this kind of question, we must first sketch our graph that is given by y is equal to square root of x. As this graph will help us to check and verify if our solution is correct. So we have here y is equal to square root of x. Now it is bounded by the x-axis, so our x-axis is equal to 0. So if x is equal to 0, y also 0. And if x is equal to 4, y is equal to square root of 4, that is equal to y is equal to positive or negative 2. To make the graph, we must create a table of values for x is equal to 0, and then y is equal to 0. And if x is equal to 4, it is equal to negative 2. Also, 4 is equal to 2. By looking our table of values, we can create a graph that looks like a parabola, since it is y is equal to square root of x. By taking the squares of both sides, that is equal, y squared is equal to x. So looking from this equation, we can picture out what is our graph here. This is the equation of a parabola that is opening to the right of our plane. So sketching our plane here by plotting this coordinates, we have 0, 0, 4, 1, 2, 3, 4, and negative 2, and 4 is equal to 1, 2. Now, from the question, the area is bounded by x is equal to 4 and the x-axis. Our graph should look like this. Now we are not to focus the area below the x-axis, since from the question it is bounded by x is equal to 0 and x is equal to 4. This is our x-axis, x is equal to 0 and x is equal to 4. So this is our area now. So by taking a rectangular strip, since it is rotated about the x-axis, so first thing to remember, if you rotate a rectangular element about any axis, for example here, it is rotated by the x-axis, so it pairs with the x, so it must be the x since we rotated about the y-axis. Then our length here is our y. This is our y. From the formula, we can create a differential volume, that is dv is equal to pi y squared dx. Now, we must express the y squared here as a function of x, since our differential volume is differentiated in terms with x. So dv is equal to pi. Now the value of y squared is by taking the squares of our equation here. This will become x. So this is x dx. Now, integrating both sides, we can create v is equal to pi integral of 0 to 4, because this is our limits of integration. We must look at the x-axis since we are integrating in terms with x. So this will be x dx. By power rule, we already know that the integral of x is equal to pi x squared, and the reciprocal of 2 is 1/2. Then we can multiply the function as 1/2, and it is evaluated from 0 to 4. Substituting all the values, we have pi is equal to 4 squared over 2 minus 0. Now, 4 squared is 16 divided by 2, 8. So we have a volume is equal to 8 pi cubic units. So this is our answer. Note that if you create a vertical strip from our graph, let's say this is our curve, and it's bounded by x is equal to 4. Now, if you create a vertical strip here, that is another solution, since the volume generated here will become a circular ring. So, we'll be talking this about on the next video. It is important to have a graph because it will guide you to answer the question. Now, we have here another example that is stated: the area bounded by the parabola AY is equal to x squared. The x-axis and the line x is equal to b is revolved about the line x is equal to b. Find the volume generated. Now, feel free to pause this video and answer it on your own. We must sketch our function. We must sketch the graph that is given AY is equal to x squared. AY is equal to x squared. Now, if we plug the value that is x is equal to b, if x is equal to b, then AY is equal to b squared. Then y is equal to b squared over a. Now, if x is equal to a, ay is equal to a squared, since x squared. Now, y will become equal to a, then since it can be cancelled out because of our values a in the left-hand member of the equation. So we have a value of y that is equal to a. So creating a table of values, x, y, if x is equal to a, y also equal to a. And if x is equal to b, y is equal to b squared over a. Sketching our graph, we have y on the x-axis, and x is equal to a, b, and here a, and b squared over a. So it is given that this equation is a parabola. By looking, we have ay is equal to x squared. From the equation of the parabola, x squared here, so it is opening upwards since it has a positive value. So our graph will be look like this. Okay. Now it is bounded from the x-axis. This is our x-axis. X is equal to 0, and x is equal to b. So we are to focus this portion of our graph, this part. Okay, by plotting, we have a, and b squared a. So we have a graph that look like this. And it is bounded from x is equal to b. Now, it is rotated, so it is revolved about the line x is equal to b, this part. By creating a vertical strip, since it is rotated along x is equal to b, So this will become our dy, and this is our length, which can be solved by taking the algebraic difference of the length. This is our x left, function of x left, and this will be our x right. By taking the difference of this length, we can have our length here. So we can express this our x, that is x is equal to x right, or the right function, minus x left, the left function of our graph. The value of xr is this line, that is x is equal to b. So x is equal to b. Okay. Now the values of xl is our graph of our function, that is ay is equal to x squared. We can get that from ay is equal to x squared. Taking the square root of both sides, we have x is equal to square root of ay. So our x left function is equal to minus square root of ay. So this is our radius of our solid. So from the formula, we can create a differential volume, that is dv is equal to pi r squared, and on our height here. So we have dv is equal to our r squared here is the x. So pi b minus square root of ay squared multiplied by dy. So before integrating our function, we must simplify the values of the parentheses here. So we have dv is equal to pi. This will become b multiplied by b. This will become b minus square root of ay multiplied by b minus square root of ay. So this will become b squared, and this will become minus 2b square root of ay. This will become positive ay dy. Now, integrating each terms, we have pi. Now, integral of b squared is b squared y, since it is a constant. This will become b squared y, and this will become minus 2b squared of a integrated from y. The integral of y raised to 1/2 dy plus the integral of ay is a 2y squared, evaluated from 0 to b squared over a. So it will become pi is equal, the v is equal to pi b squared y minus 2b squared of a. Now, integrating y raised to 1/2 is equal to adding 1 to the power. We have 1/2 plus 1 will become 3/2. So this will become y 3/2, and the reciprocal of our power here multiplied to the term. So this will become 2/3 plus a 2y squared integrated from 0 to b squared of a. Simplifying, before we evaluate the limits of integration, we have pi is equal to b squared y minus 4/3 b squared of a y raised to 3/2 plus a over 2 y squared evaluated from 0 to b squared over a. Now, we have pi is equal to b squared. Now, our y here, b squared over a, so this will become b squared over a minus 4/3 b a raised to 1/2 and our y here is b squared over a raised to 3 halves plus a over 2, our y is b squared over a raised to square minus 0. Okay, simplifying, we have pi is equal to b4 over a minus multiplying b squared to the power 3 halves. The 2 will be cancelled out, so we are left with b raised to 3, and b raised to 3 multiplied by b raised to 1 is simply b raised to 4. So we have 4 thirds b raised to 4. Now, 1 half, we have the power of a is 1 half, and the power of a here is 3 halves. But according to the power rule, we have a 1 half minus 3 halves. So this will become 1 minus 3 is negative 2, negative 2 over 2, so our a is equal to negative 1. So we have 1 over a here, and the next term, we have b squared raised to square is simply b raised to 4, and we have also here a, the power of a here is 1, so we have a raised to 1 minus 2, we are left with a raised to negative 1, so the term also equal to this, to a. Notice that we have a common factor here, that is b fourth over a. So if we factor out b fourth over a, we are left with 1 minus 4 thirds plus 1 half. Taking the LCD of our terms inside the bracket, we have pi b raised to 4 over a. So the LCD here is 6, since it has a common factor of 6. That the lowest common factor of 3 and 2 is 6. So we have 6 multiplied by 1 is 6, minus 6 divided by 3 is 2, multiplied by 4 is 8. 6 divided by 2 is 3, multiplied by 1, 3. So simplifying, 6 minus 8 is negative 2. Negative 2 plus 3 is 1. So we are left with volume is equal to pi b4 over 6a cubic units. This is our answer. Now we have here another example that is stated as the area bounded by the y-axis, the line y is equal to 1, and that arc of y is equal to sine x between x is equal to 0 and x is equal to 1 half pi is revolved about the line y is equal to 1. Find the volume generated. Now feel free to pause this video and answer it on your own. First things first, we must sketch our graph. The graph of y is equal to sine x. Now, to solve this problem, we need some values of x and y to plot our graph. So if x is equal to 0, y is equal to sine 0. Sine of 0 is equal to 0. Now, it is bounded by x is equal to 1 half pi. So it is given in terms with the pi. So we must set our calculator in terms with radians. So 1 half pi is equal to 90 degrees. So we have here pi halves. 60 degrees here is pi thirds, and the 45 degree is pi 4, and the 30 degrees is pi 6. Now, by substituting our angles here to our function for y, if x is equal to pi over 6, then y is equal to 1/2. Now, if x is equal to pi over 4, y is equal to sine of pi over 4 is simply square root of 2 over 2, or approximately is equal to 0.707. If x is equal to pi over 3, then y is equal to sine of pi over 3 is square root of 3 over 2, or approximately equal to 0.866. And if x is equal to pi halves, then y is equal to sine of pi halves is 1. So making our table of values, we have x, y, and x, when x is equal to 0, we calculate that y is equal to 0. And if x is equal to pi over 6, then y is equal to 1/2. And if x is equal to pi over 4, y is approximately equal to 0.707. Now, if x is equal to pi over 3, it is approximately equal to 0.866. And lastly, if x is equal to pi over 2, then y is equal to 1. By sketching the graph, by plotting the points generated to our table of values, we have the y-axis and the x-axis. Now, x is equal to 0, and then this will become pi over 6, this will become pi over 4, this will become pi over 3, and pi halves. And this point will be our 0.5, and this point will be our 1. Now, from the question, it has a line that is y is equal to 1. So we have here y is equal to 1. This will become y is equal to 1. And it is bounded by x is equal to 0. This x is equal to 0. And x is equal to pi halves. Or we have 0, 0 here. Pi 6 here. Pi 6 or y is 0.5. Then pi 4 is around somewhere here. And pi thirds is, and the y here is 0.866. We have, and the point is around here. And lastly, pi halves. When x is equal to pi halves, then y is equal to 1. We have point here. Tracing the points we have created, then our graph will look like this. This is our function y is equal to sine x. Now, note that it is rotated along the line y is equal to 1, so it then rotated y is equal to 1 here. So notice that it is rotated along the x-axis. This will be our x-axis. So then we create a horizontal strip having the base as our dx, and this will become our length, in which it is equal to 1 minus y. Now, why it is equal to 1 minus y? Notice that this length and this length is equal to 1, right? Is equal to 1. Now, if we take here and this one, if we take this one as our unknown, it is y. So if we minus 1 minus 1 minus y, now you may question why it is equal to 1 minus y. Notice that the length here and this length is equal to 1. And this is our unknown value, this one. And this one, we denote this as y. Now, if we subtract this 1 minus y, then we can have the length that is equal right here. So our variable length here is equal to 1 minus y. We can create a differential volume. If we rotate this rectangular element along y is equal to 1, it generated a circular disk. So that circular disk has a differential volume. That is dv is equal to pi. Then our r here is 1 minus y, so 1 minus y squared multiplied by the height will be dx. Okay. Before we integrate this differential volume, we must simplify first our function that is equal to pi 1 minus 2y plus y squared by taking the product of the two terms of 1 minus y, dx. Also, before integrating the term, we must substitute the value of y here. Since from the question, our y is equal to sine x, then substituting all the y with sine x, dv is equal to pi 1 minus 2 sine x plus sine squared x dx. Integrating the differential volume, we have v is equal to pi integral of 1 minus 2 sine x plus sine squared x dx is evaluated from 0 to pi halves. Now, why you may question that why it is 0 to pi halves? Since we integrated in terms with x, so therefore we must look the limits of integration with respect to x. So in our graph, we have the graph is bounded by x equal to 0, so the lower limits of integration will become x is equal to 0, and the upper limits of integration will become x is equal to pi halves. Okay. Now, evaluating the integral, we have the volume is equal to pi. The integral of 1 will become x, and the integral of sine x is negative cosine x. And negative multiplied by negative, we have positive 2 cosine x. Now, evaluating this, we must transpose it into equivalent value. So we have from the trigonometric of identity, sine squared x is also equal to 1 minus cosine 2x over 2 dx, evaluated from 0 to pi halves. This is equal to pi x plus 2 cosine x. Separating the terms, we have 1 half dx minus cosine 2x over 2 dx. So we have pi x plus 2 cosine x plus the integral of 1 half will become 1 half x minus differentiating the 2x, we have 2. Reciprocal of 2 will become 1 half, and 1 half multiplied by 1 half will become 1/4. And the integral of cosine is sine, so it becomes sine 2x. And it is evaluated from 0 to pi halves. Now, evaluating the limits of integration, we have pi is equal to, this will become 1 half x plus x is 3 halves x. So 3 halves multiplied by pi halves plus 2 cosine pi halves minus 1/4 sine of 2 multiplied by pi halves. And then we minus by the 0, by the lower limits of integration, we have 0, that's 3 halves x is 0, so minus 2 cosine of 0 minus the 1/4, it will become positive, so positive 1/4 sine of 0. So notice that the cosine pi halves is the cosine of the 90 degrees, since this will become 0, and also this will become 0 since sine of pi is 0, and the sine of 0 is 0, and the cosine of 0 is 1. So we are left with pi, 3 pi over 4, so it becomes 0, 0, 0. This will become 1 multiplied by 2 is negative 2. So this will become negative 2. And further simplifying, we can also write this term as pi over 4 multiplied by 3 pi as 8 cubic units. So this will become our volume. Thank you for listening, and God bless and good luck to your exam.